Combining polynomials. Lesson 8.1. You are watching this video with Ms.Y. Cavazos. So, combining polynomials. Combining is exactly what it sounds. You're going to add or subtract. Before we do that, I want to review something that was done a few days ago, which dealt with combining. In this case, we had to combine radical expressions. So in order to be able to combine radical expressions, there's two things we had to look for: the index and the radicand. They had to be identical. So in this problem here, we have 29 square root of 6 minus 11 square root of 6. We check the radical. It has the same radicand and the same index. That means we can go ahead and combine them. So we're going to focus on 29 minus 11. Since square root of 6 is what they have in common, then square root of 6 is what the answer is going to have as well. 29 minus 11 is 18, so we get a simplified answer of 18 square root of 6. This next example here, we have 18 square root of 5 plus 16 square root of 3 minus square root of 5. In pronouncing it, you understand and you hear clearly that there are two square roots because the index is 2 and the radicand is 5. There's two square root of 5s. So what I'm going to do is rewrite this expression and make sure that my like radicals are next to each other. This one doesn't have a coefficient, so what I'm going to do is put a 1, and then at the end we're going to throw in 16 square root of 3. What we're allowed to do is combine these two like radicals, and we're going to focus on 18 minus 1, square root of 5 is what they have in common, and just bring down 16 square root of 3. 18 minus 1 is 17, with the square root of 5, and just keep bringing down 16 square root of 3. There's nothing else we can do here. This is as far as this problem goes. That is our simplified answer. So with that being reviewed, this brings us to today's lesson, like I said, combining polynomials. So today you will be combining polynomials by adding or subtracting like terms. A blank is a monomial or the sum of monomials, each called a term of the polynomial. So this is a polynomial. New vocabulary word. It may have different monomials, and we'll get to, well, what's a monomial? Next one is a blank is a number. It could be a variable, or it could be the product of both. That means a monomial, because there's one term. That's why it says a term. There's only one. The blank is a sum of two monomials, two terms. So what could we use for two terms? So if mono means one, then bi means two. Binomial. Next one, a blank is a sum of three monomials, three terms. So this would be a trinomial. And finally, a blank is a monomial that is a real number, no variables. So if it's just a number, then that's our constant, something that has been mentioned since the beginning of the year. Okay. What we're going to do is we're going to determine what from here is considered a monomial, a binomial, a trinomial, and a constant. So here we have three things, as you may say. These things are called terms. We have a 36, that's a term. We have an x term, because it has a variable x. And we have a y term, because it has a variable y. There are three components, three terms, so this is called a trinomial. And again, 3 terms put together to make an expression. This one, we have a constant and we have the n term, 2 terms in total. So this is our binomial. Again, 2 terms. This next one, 13x, yeah, there's 2 things in there, but this whole thing is put together and it makes it a monomial because it's 1 term. This is an m, 1 term. So finally we have this constant, this number. So by now you know this is a constant, a number that is by itself. But this is also a monomial. Because if you remember the definition, monomial could be a number, a variable, or the product of both. So, let's move on. Standard form, something important about a polynomial, and this is a polynomial. This whole thing is what we call a polynomial. Why? Because it has a bunch of terms. In this case, there's more than 3, so I'm going to make a note of it. I'm going to put 4 terms. So there's not a word for it when it has more than 3, so we just call it a polynomial. Polynomials are arranged in a certain way so they can be easier to work with. They're arranged in descending order. What does that mean? That we're going to look for the highest degree, the highest power. So I'm going to circle all the powers. This has a power of 1. This doesn't even have a power. And this has a power of 3. If we look at all of them, we notice that, hey, 4 is the highest power. So we start off with 4. This is the highest degree. Descending order means you're going to, in a descending order, you started with 4, the number that is right below is 3, which is why this term, the negative 12x cubed, is next. After that is the squared, so we're going to move this term there, the 18, and it's positive, that's why there's a plus sign. Then we move on to the one that had a power of 1, which is this minus 12. Notice that the minus sign goes with the 2. And then finally we have the constant, 21. So the way this was arranged is called standard form. So what we're going to do first is we're going to arrange each polynomial in standard form. Once we do that, we're going to identify the leading coefficient and the highest degree. So before we answer those questions, we need to write it in standard form. Descending order. So we look at all the exponents. Okay, this one is the highest one, so we start off with that one. 2y to the power of 4. And I'm going to cross it off so I know that I used it. Next we have power of 3. So we move that term over. Minus 6y to the power of 3. There's no power of 2. So we move on to the next one, which is power of 1. So the 5y term, and 5 is positive, goes right after. And finally we have our constant. The constant always goes at the end. So what is our leading coefficient? Looking at this whole polynomial, what we wrote here, what's the number at the very front? Who's the leader of this whole polynomial? 2. The coefficient is 2, so that is our leader, our leading coefficient. The highest degree is, what's the highest power that this polynomial had? 4. So the highest degree is a 4. Next example. 8 minus 2n squared minus 4n to the 5th minus 3n. So we look at all the exponents. This has a power of 1. And we decide, okay, what's the highest power? 5. So that term, 4n to the 5th, now don't forget the 4 has a minus, so it has to be included. There's no 4th power, there's no 3rd power, we move on to the 2nd power. So then this term moves after 2n squared. Then we have power of 1 to the next term, and then finally 8 again is our constant. So who is our leader of this polynomial? The negative 4. Not just 4, the negative 4. What's the highest degree? What's the highest power? What's the highest exponent? 5. Okay, so with this being said, now we can go ahead and combine them. So how do we combine? We add or subtract. So in this expression here, we have a trinomial, because it has 3 terms, plus another trinomial, because it has 3 terms. When we add, it is easy for us to just remove the parentheses and rewrite the whole expression without the need of having parentheses. Next, we're going to use the commutative and associative property. Commutative property means move around. So we're going to move terms around, and we're going to start off with our like terms. So I look at all the exponents. The highest is a 2. So we're going to start off with 2x squared and move this one right after, because those two are together, like terms. Next, we use the ones that had a power of 1. And that is the 5x, and 5 is positive, and the 6x, which is also positive. Finally, we deal with the constants, which is a negative 3 plus a 3. Okay. Finally, associative property, which means put them together in groups. So here we have these two, and these two. Our final answer is what we get when we combine those like terms. So here we have 2 minus 4. So it's kind of like saying, okay, focus on 2 minus 4. What do they have in common? The x squared. So in other words, here we have 2 minus 4 is negative 2. So we have a negative 2x squared. 5 plus 6 is the same thing as saying focus on 5 and 6, keep the x. Well, 5 plus 6 is 11, so that gives us 11x. Then we have negative 3 plus 3 is just 0. But do we need that 0? No, we don't. Finally, what's our leading coefficient? Who is the leader of this polynomial, of this binomial? Negative 2. What's the highest power, the highest degree? A 2. Let's try another example. Here we have a binomial adding with a trinomial. So again, if it's addition, which is the case for this problem, and that doesn't even look like an arrow, there we go. If it's addition, we can remove parentheses and just rewrite this whole expression like this. We want to put it in descending order already. So we want to start off with writing the highest degree, the highest power. And since that's the only y squared, we're going to bring it over and write it down. Then we look for the other continuing terms that follow right after. In this case, it would be the 3y. 3 is positive, so there has to be a plus something in between these two terms. Then we bring down this 4, minus 4y. Then the constants, which is minus 5 plus 8. Associative, so that was commutative property. Associative property says put together the like terms. Combine them. So y squared is the only one, so y squared doesn't change. 3 minus 4, so focus on 3 minus 4, and they have the y in common. So 3 minus 4 is negative 1, so minus 1y. Next one we have negative 5 plus 8 is a positive 3, so plus 3. Now do we really need to put that 1 there? No, we don't. So I'll just erase it. Now who's the leader of this trinomial? Because there's 3 terms, the 4. What's the highest power? A 2. Next one. Now it's time to find the difference. Here is where things change a little. Minus sign. We can't just remove parentheses. We have to put a 1, and we got to distribute that negative, or that negative 1. So what's going to happen with this first trinomial is that we're going to rewrite. This second trinomial, we're going to distribute. So negative 1 times 4 is negative 4n. Negative 1 times negative 5 is a positive 5. Negative 1 times 3 is a negative 3n squared. Commutative property. Combine your like terms. So those with the power of 2 go first. So 2n squared minus 3n squared. Those with the power of 1 go next. So that's a 2n, and that 2 has a minus. 4 also has a minus. And then finally the constants, the 3 and the 5. Combine your like terms. These two are like terms, so they go together. And that is 2 minus 3n squared. N squared is what they have in common, so we got to subtract. 2 minus 3 is negative 1, so it starts off with negative 1. Negative 2 minus 4. These two like terms is the same thing as saying focus on negative 2 minus 4. They have n in common, so keep the n. Negative 2 minus 4 is just negative 6. Then 3 plus 5, well, that's just 8. So plus 8. Who is the leader of this polynomial, of this trinomial? Negative 1. Highest degree? 2. Let's try another one. That minus changes things. Do not ignore it. Put a 1. This whole first polynomial, or binomial in this case, just bring it right down. Distribute the negative, so negative 1 times 3, negative 3. Negative 1 times negative 3x squared, positive 3x squared. Negative 1 times 6x, negative 6x. Commutative property. Combine. Rewrite, I'm sorry. So negative 3x squared with a plus 3x squared. The next term is the ones with the power of 1, those two. So then we have a positive 4x and a minus 6x. And then at the end we have a minus 3. We combine negative 3 plus 3. Type it in the calculator. That is 0. 4 minus 6. Type it in the calculator. Bring down the minus 3, and okay. Who is the leader of this final answer? Now before you say 0, it is not 0. Why isn't it 0? Because that's not really there. If it's a 0, then it's not really there. So that means that this is our final simplified answer. That's the one we paid attention to. So in this case, the leader is a negative 2. And the highest degree, the power of this x, there's a 1, so the highest degree is a 1. Thank you for watching. I hope this helps.